down as well. We're going to start by assuming that both companies have exactly the same cost structure. So neither has a comparative advantage in the production of this new airplane. And the decision is, I'm either going to produce or I'm not going to produce, which I don't know what other decision you could make, produce half an airplane. And we'll assume that there's free trade, or at least no trade barriers. So when we run into a duopoly case like this, now we have to think about what Boeing's decision is going to be. And we know that Boeing's decision will depend in part upon what Airbus decides to do. And Airbus's decision on production also needs to take into account what Boeing is going to do. So this actually becomes a game theory issue. So we're not going to get deep into game theory, but we'll do a little bit here. So this is what we refer to as a payoff matrix. And the way that this works is we've got Airbus on all the upper right triangles of each quadrant, and Boeing will be on the lower left triangle in each quadrant. And you can see that Airbus can decide to produce or not produce, and of course those are exactly the same decisions that Boeing has. So what we want to think about then is how much money each of these firms would make on various different decisions that they can do. So to start with, let's look at the lower right quadrant. Okay, this is a quadrant where neither firm is going to produce the airplane. So if neither firm produces the airplane, their profit should be 0. That part's easy. Now, let's look at the lower left quadrant. So in this lower left quadrant, what we have is Airbus is producing, and Boeing is not producing. Boeing not producing is pretty easy. Their costs or profits will be 0. And we'll assume that Airbus's profits will be 100. Now remember, we assumed that both Airbus and Boeing had identical cost structures. So if we look at the upper right-hand quadrant, where Boeing produces but Airbus doesn't, we should just take the lower left quadrant and flip it. So in this case, when Boeing produces and Airbus doesn't, Airbus has 0 profits and Boeing has 100. Now, that only leaves the upper left-hand quadrant, and this is a case where both of the firms are going to produce the product. Now remember, if both of them produce the product, they're going to split the market. Right? So down here, Airbus has the whole market. Up here, Boeing has the entire market. But if they both produce, they're going to end up splitting the market. Since neither has a cost advantage over the other, we might think that, well, maybe they'll share the market 50-50. But in any case, each of the firms will be producing at a smaller scale than if they had the entire market to themselves. We assume economies of scale in production. So if we're producing at a smaller scale, then our costs are going to go up. And let's just assume that if both produce, each firm will end up losing $5 or $5 million. So this thing gives us a payoff matrix. Now, what we have to decide is, where are we? Which of these quadrants do we end up in? And so we've got to come up with some solution to the game. And the way that we do that is, for each firm, we have to make our own best decision, taking into account what our rival may do. When we do that, the outcome is referred to as a Nash equilibrium, named after John Nash, who was a mathematician and game theorist who won the 1994 Nobel Prize in economics. What's less well known is that a professor from Berkeley co-shared the Nobel Prize with John Nash, but because John Hayani didn't go crazy, they didn't make a movie about John Hayani. Okay, so here's our production decision, or payoff matrix. So let's take Boeing's case. So we need to figure out Boeing's best decision, which, by the way, may be plural. So the first thing we want to ask ourselves is, suppose Airbus decides to produce. If Airbus decides to produce, what is Boeing's best option? So if Airbus produces, then Boeing wants to not produce. If Boeing produces, they will lose $5 million. But if they don't produce, they will not lose anything. They won't make anything, but they won't lose anything. Yes? Well, we have economies of scale, right? So I'm only selling half as many as I would if I own the entire market. Okay, yeah. Well, what if it costs a lot to produce 50? I mean, if you have very high fixed cost, which, by the way, you do in this industry, then you could end up losing money on each one. Okay, so this then is a Nash equilibrium. Okay, that gives us Boeing's best decision if Airbus decides to produce. However, from Boeing's perspective, we also need to take into consideration what happens if Boeing decides not to produce. I'm sorry, if Airbus decides not to produce, thank you. So if Airbus decides not to produce, notice that Boeing's best decision is, well, heck, if they're not going to produce, I'll own the market, so we'll be in the upper right-hand corner. This is also a Nash equilibrium. So in this particular case, we have 2 Nash equilibriums just for Boeing. But we've at least identified what Boeing should do. And notice what Boeing should do depends upon what they think Airbus is going to do. Now let's think about it from Airbus's perspective. So from Airbus's perspective, we want to say, what will we do if Boeing decides to produce? And if Boeing's going to produce, it makes the most sense for us not to produce. And again, this becomes a Nash equilibrium. Now Airbus says, well, what if Boeing decides not to produce, for whatever reason? Then the Nash equilibrium is for Airbus to produce. So notice that we end up with the same two Nash equilibriums for Boeing and Airbus. When you have two Nash equilibriums, you don't have a unique solution. There's not an answer to the game. So something needs to happen to produce a win for somebody. So one of the things that could happen is we could end up with the winner being who starts first, who has what we call the first mover advantage. Now this could be very important. In the recent real-world case of the super jumbo Airbus 3, what is it, gazillion? I don't know, the one that holds 800 passengers, that they have to build new terminals to land this thing. So Airbus has this giant airplane that they're now producing. And 15 years ago, it was unclear whether Airbus was going to produce or Boeing was going to produce, or both of them were going to produce this giant airplane, super jumbo jet. And they spent lots of money early on, and Boeing decided to drop out. And the reason that Boeing decided to drop out is because Airbus had a big enough head start. So Airbus, in this case, had a first mover advantage. So let's see what that means. Okay. So notice, in this particular, in the example I just gave you, Airbus has a first mover advantage, which means they can get into production first. So notice, once Airbus starts producing, Boeing's best strategy is to not produce. And so Boeing drops out of the market. Now that hasn't happened in every competition between Boeing and Airbus, but it has happened in those few cases where the market, the perceived market, is actually relatively small. So again, if you have huge fixed cost, as we have in the aircraft industry, and what is perceived to be a relatively small market, then you're going to end up with a payout matrix that might look something along these lines. So that first mover advantage can be really important. Now the question then becomes, is there something that government can do, that the government can do, to overcome this first mover advantage? Now notice, in this case, Boeing, the example I gave you, Boeing doesn't end up making any of the airplanes, these super jumbo jets, which means Boeing doesn't hire all those workers. The government may want to expand production in the airline industry and employment in the airline industry, and so it may look for how can we do that. So as we've seen, we can add a cash subsidy or a production subsidy to the case. So here, I've switched on you. We're going to assume that Boeing has the first mover advantage, not Airbus, although in the super jumbo jet, Airbus did. And now we want to have the EU government give a $25 million subsidy to Airbus if it produces. So this was our original payoff matrix. So we need to change it for the subsidy. So notice, if Airbus produces while Boeing's also producing, rather than losing 5 million or whatever it might be, they will actually make 20. The loss of 5 million plus the subsidy of 25 million. And if they produce and Boeing doesn't, now they make 125. So now we can think about going back and reassessing the Nash equilibriums. So notice that in this case, if Airbus decides to produce, Boeing's best profit maximizing decision would be to not produce. And if Airbus decided not to produce, obviously Boeing is going to produce. But if we look at it from Airbus's perspective, there's nothing to deter us. If Boeing produces, it still makes sense for Airbus to produce. If Boeing doesn't produce, it still makes sense for Airbus to produce. So for Airbus, there's only a single Nash equilibrium, and it's the lower left-hand quadrant. So Airbus will always produce under these circumstances, and Boeing's best decision is not to produce, to give the entire market to Airbus, which is what ends up happening. So now we just have a single Nash equilibrium, and Airbus owns the market. Yes? Yes. Okay. So yeah, well, they might be. So what would Boeing do? Yeah, they just stop, right? Because as soon as Airbus starts producing, now Boeing starts losing money, and it'll continue to lose money as long as Airbus produces, and there's no reason for Airbus not to produce as long as it has the subsidy. So once Boeing knows that the subsidy will be made to Airbus, there's no reason for them to continue to produce, and they drop out of the market. Okay, so we want to also ask ourselves, how would we, by the way, this should not be changing, how would we assess the welfare conditions that are taking place here? Yes? We'll talk about that in just a minute. So the question was, if the EU government gives Airbus a subsidy, would the US government give Boeing a subsidy? So we'll come back to that in just a second. So what we know when we look at this decision is that Airbus's profits are now 125. Plus, it cost the EU government 25 million to actually generate those profits for Airbus. So the net effect in Europe is that there's a gain of, or there is a net effect on European welfare of 100. Yes?
Why wouldn't the European government structure it so they only pay the subsidy if Boeing produces? That way they scare Boeing into producing it, and they don't pay the subsidy.
Well, because governments aren't that smart. Now remember, Boeing is only going to not produce if they believe that the payments will be credible, right? So yeah, I mean, you could think of lots of different alternatives here, but yeah, I mean, if it was a credible threat, then presumably they could fool Boeing once. I'm not sure I'd want to do it on the next round of airplanes. Okay, so let's think about what is happening here. So Boeing knows that it will lose money. Boeing will lose money if it produces. because Airbus is going to produce regardless. So Boeing is deterred from actually entering the market altogether, even though it had that first mover advantage, which was what our assumption was. So in this case, the subsidy raises the profits by much more than the subsidy because of the deterrent effect that takes place. Now again, remember, this only works if you have a very high fixed cost industry with actually a relatively low marginal cost. So you have these economies of scale that are significant. If cutting the market in half doesn't generate significant economies of scale, then this is unlikely to deter anybody. So in this case, we say that the subsidy has had this strategic advantage for the EU. It's overcome the first mover advantage that Boeing actually had. So this is what we refer to then as strategic trade policy. We're using a domestic subsidy, production subsidy, to alter the outcome of the market result, right? Similar to the way we've used tariffs or import quotas or export subsidies to alter the outcome. But here, notice that only one of the countries is actually ending up with the entire industry or the production of this particular product. This is sometimes also referred to as the Brander-Spencer analysis. Who were the two economists who dreamed all this stuff up to torture international trade students. Now notice that strategic trade policies are basically beggar thy neighbor policies. What Europe gains is at the US's expense, or what Airbus gains is at Airbus's expense. I mean, what Airbus gains is at Boeing's expense. I get it right, yeah. Okay, I think I'll take Thursday off. Okay, now, the question was asked, well, wouldn't the US government do something? Again, let's assume Boeing has the first mover advantage. The EU provides a $25 million subsidy if Airbus produces, and now the US government rides to the rescue, providing a $25 million subsidy to Boeing if it produces. Okay. So again, this was our original payout matrix. So it's pretty easy to figure this out because the subsidy payments by the governments to their own producers are exactly the same. So here, if Boeing produces or if Airbus produces, they'll both lose $5 million on operations, gain $25 million from the subsidy, so they've netted 20. If Boeing produces but Airbus doesn't, Boeing will earn 125. If Airbus produces and Boeing doesn't, Airbus earns 125. Now where's our Nash equilibrium? So notice that if you're looking at it from Boeing's perspective, if Airbus produces, it still makes sense for you to produce. And if you look at it from Airbus's perspective, even if Boeing produces, you still make money if you produce. So our Nash equilibrium here is now in the upper left-hand corner, and it makes sense then for both companies to produce. So now, of course, we split the market. We're suffering economies of scale, which is why our total payout, even though it's positive, is not nearly as great. So if we look at Airbus's profits, we would see that those were 20 million. The EU government revenue is going down by 25 million. So the net effect on European welfare is minus 5. Oh, that doesn't sound so good. And if we looked at it from the US perspective, Boeing's profits would also be 20. But it cost the US government 25 million. So the US welfare is off by 5 million as well. So notice that if both countries' governments provide subsidies, then we end up with the outcome where both firms are now producing. So there's no deterrent effect, nobody gets a strategic advantage, and both countries are worse off. Anybody want to guess what actually takes place between Airbus and Boeing and the EU government and the US government? This is the outcome. The EU government subsidizes Airbus, the US government subsidizes Boeing. It's not clear from most of the market research studies that it's made a huge impact in terms of the distribution of sales of aircraft around the world, and it's been in legal dispute for 25 years. So the attorneys are getting rich, but